game plan this week. Today, peer review day. I just want to go through, I will go through everything, but I want to try to focus on what we're doing right now, which is chapter 4. So if you do have questions out of chapter 3 that we've already taken the test on, yes, I will answer those and we'll go through that stuff. But basically what my plan was today, try to get everybody caught up, get to 4.1 through 4.3, and that's that. By the way, I was planning on having like grades posted and updated and all that stuff, because remember how on Friday I sent out that message on Friday that said, hey, I think I'm going to turn my computer off a little early today. If you have homework that you're going to turn in, to just bring it on Monday. Yeah, I turned my computer on this morning and there was like 25 assignments turned in over the weekend, so I tried to like grade those this morning. Yeah, appreciate that. Thank you. Thank you. See, that's exactly what I wanted. But no. 5 minutes later, you like, jeez. So anyway,
You want to see? He put a sticker of pit vipers on his face.
Oh yeah.
Dude, you literally just covered up your whole like nice.
Now, FYI, end of semester is rapidly approaching. This is actually the last full week of this calendar year that we'll be in school. Because next week we don't have school on Monday.
You don't?
No, it's Martin Luther King Day.
Oh, sweet. Never did.
So no school on Monday next week. So we have a full week this week. Next week is only Tuesday through Friday. And then
Why are we still taking midterms? Why
um
are we doing that?
Push them back like
Like, push them back or something.
Abby, it's not my fault. Everyone had you alone.
Shut up.
I tried to. And then you start crying.
what midterm, I mean we're still having midterms for the same reason we always have midterms. I mean, still.
Here's like, I'm not gonna. There's a.
We weren't in normal school, but we were still in school. You were still supposed to be doing stuff and learning stuff. So,
Is y'all's tree still up?
no, I take mine down December 27th
Ours is
every year.
long.
I think ours is, yeah.
No. This year we kept it up a little bit longer, but normally, yeah. Like, actually, I was surprised at my wife this year. On December 26th, all Christmas decorations were put away other than the tree. Yeah.
My dad had to work on Christmas.
And the next morning, she started putting stuff away. Like, you're putting stuff away already? Yeah. Okay. Sounds good. But in her defense, we also had them up earlier than normal this year too. So they were up a long time. So. All right. So
Santa brought us a tree.
let's do this. Everybody open up to page 233. Game plan today is we're mainly going to try to focus on chapter 4, get everybody kind of caught up on chapter 4. The only reason I brought up the end of the semester is if you owe me stuff, we need to start getting that stuff turned in. Like, end of semester is rapidly approaching. If you owe me tests or quizzes and things like that, you need to come to AAA, start getting stuff done. I mean, so I will have grades in Skyward updated probably by the end of 4th hour today. I'll wait till I do want to make sure I get those assignments that you guys turned in online over the weekend put in before I post them. But look at your missing assignments, not only in my class, in all of your classes, and make sure you're getting caught up before the end of the semester. With exams approaching, you want to be able to be focused on the exam and studying for the exam and preparing for that, not crash trying to get missing assignments caught up. Yes?
We take this stuff in the gym.
Say that again?
We take these tests in the gym. We do it in the classroom.
No, these are in classrooms. The only tests you'll ever take in the gym are like the PSATs.
Yeah, that was hard.
In fact, the actual SAT, we now do in classrooms too. So, yeah, we changed. What? Okay. But yeah, it'll all exams are in your classroom. You have the only difference is we're on a half-day schedule, but you only go to 3 class periods that day because you. And by the way, because you guys are freshmen, the way we do our exams is on Tuesday we take your first and second hour exams, just like normal, right? So you go to first hour, you'll have, I think it's an hour and a half to take those exams. Huh? Yeah. So you go to first hour, we could have an hour and a half to take that exam, might even be almost 2 hours. And then we have like a 15-minute break, and then you have second hour exam, and then we're done for the day. On Wednesday that week, you go to fourth hour first, then you have a break, and then you go to third hour. So that Wednesday, it's backwards. We do that for the tech kids because the tech kids have to go to tech after third hour. So if we did third hour first, they'd have to come into school normal time, take their third hour exams, and then just sit around and wait for 2 hours before the bus goes to tech. So by doing it this way, they just get to sleep in a little bit, and then they come in, take their exam, and go straight to tech. So it works out a little bit better for them. And then Thursday, yep, you do 5th and 6th, normal, and you go home. Huh? We usually have Friday off that week. So.
This is the Monday that we got off?
No. So, we are here. We're the 11th. This week's a full week, Cameron. This week's a full week. The 18th, you have off. I'm talking about the week of the 25th. This is exam week. So our exams are that Tuesday, Wednesday, Thursday, and then that Friday's off. Next week is I'm planning, so here's my basic plan. Today, I'm going to review the first 3 sections. We're up to this point. Tomorrow, I'm teaching 4-4. Okay? And then Wednesday, we're going to recap. Thursday, quiz. Okay? Friday, I'm going to do 4-5. Monday, I'm going to do 4-6. And we're done with chapter 4. Okay? I might put another quiz just on these last 2 sections next week, but I might just, depending on how it goes, say, I'm just going to put this chapter 4 on the midterm and not even give you any more quizzes or tests. That's a good thing in that it's less for you guys to do as far as quiz and tests in this class, but it's a bad thing because it also takes away opportunities to raise grades. So if, let's say you're at a 50 and you need, you turn homework assignments in, it doesn't raise your grade that much. You might need another test to have the opportunity to bring your grade up. So it's bad for that part because it doesn't give that opportunity. So, but I do want to finish up chapter 4 before the exam, and then we'll just, to me, I'm fine with just putting it on the exam, but if you are in a situation where you need the points to bring your grade up, you'll just have to talk, and maybe we'll work out an optional type test on chapter 4. Yes? At you? No. So there might be a situation, I've done it in the past, where, I have you sign up on AAA to take a retake. I might have you sign up to take an optional test. And it's not a retake, it's just, if you want to take the chapter 4 test, you can. If you don't want to, then don't, kind of thing. So it won't hurt you.
Did you ever go to school? Like,
Did I come in and work? Only for like the first week, and then I stayed home and worked from home. Huh?
Were you out in school on the Zoom or
No, I was at home. The first week I was here, but then after that I worked from home. So. Yeah. All right, so page 233, section 1. All the graph stuff. This section, it looked like from the homework, you guys thought this was a really easy section. The biggest thing out of this section is the difference between continuous and discrete. What would be an example of when you would need to use or want to use a discrete graph? What is a discrete graph? So you're looking at page 233, like 7, 8, 9. Which one of those is discrete? 9. Why is 9 discrete? It's broken. It's dots, right? A discrete graph basically is broken. So it's only a set of points usually. What would be a real-life example where you would want to use a discrete graph and not a continuous graph? There's very creative of you, calories and servings. Why calories and servings?
They are going up. They're not going down.
Think of it in terms. So, let's say we charted number of people in school on each day. So today there's 642 kids in the building. Tomorrow there might be 644. The next day there might be 640, right? So why would that type of situation where we go on Monday, there's 640 students. On Tuesday, there's 642. And on Wednesday, there's 638, whatever, right? Why would that be an example for a discrete where it's broken? Here's basically the question. Is there a point in here? Should there be a point in here? Why? There's nothing between Monday and Tuesday. We're not doing like a continuous time thing. And can you have a half of a person? No, it just doesn't make sense, right? So basically, if you can only have certain numbers of people, you can't have half of people, and we're only talking days of the week. Now, we could also change that to, we could change this to time, and we put it at 7 o'clock, 7:01, 7:02, 7:03, and would that be better for line or discrete? Same situation. We just do it over the course of the day, where we say Come on, computer, don't do this to me. We're down here, we put 7 o'clock, 7:01, 7:02, right? And we say basically there's like 2 people in the building here, and then there's 3, and there's 3, and there's 4. Would that still be discrete, or would we want to make that more of a line graph?
You want to count the sections if you realize that.
Well, it makes more sense now that we're breaking it up. We could break it up by time to do line here. But even going this way, can we still have half a person? Or is it going to jump immediately from 2 to 3? So now that still should be discrete. Now, I disagree with the book on the calories and servings for one reason. Can you eat half a serving? Yes, you can. Can you eat 1/10 of a serving? Yeah, it's just a bite basically, right? So, yes, that to me becomes something where you can have more of a continuous graph versus a discrete graph. Does that make sense? So, why on number 8, where it's comparing your age and your height, why did they do continuous graph? Yeah. Abby, how tall are you? 5'8". Was there a time in your life, any day of the week, any time of your life, that you were 5'3"? Yep. Was there a time in your life that you were 5'3.5"? Was there a time in your life that you were 5'3.6432"? Yes, there was. Like, you don't jump an inch instantly. You grow slowly, right? There was a point in your time in your life where you were all those decimal points, right? So that's more of a continuous growth. Does that make sense? If you put a hose in a pool and you're filling it up and you want to chart time and water level, is that going to be a discrete or a continuous graph? That's continuous. How could you do, what would be a situation where you're filling up a pool where you'd want to use discrete? Huh? I would say if you're filling it up with a bucket. So now you're pouring 1 bucket in, you're pouring 2 buckets in, you're pouring 3 buckets in. You still could go half a bucket, but if you assume that you can only do full buckets, now it would be about the only situation you'd want to do a discrete graph. Make sense? Somebody describe number 8. Like, what happened in that graph? Like, what's going on for that whole graph?
Like the older she gets, or he gets, or whatever, she like has a growth spurt. And, like,
Where did she have a growth spurt?
I don't know.
Well, in the beginning, the end, okay, right in the middle. So early on, what was happening? She was born, how tall was she? 0. So right at the 0 point, right? And then what happened the first part of her life? She was growing, but not only growing, she was growing. Huh? To me, I would say she was growing at a continuous rate. Exactly the same rate. How did I know she was growing at a continuous rate? It's a straight line. It's a straight line going up, right? Then, what happened right in the middle? She had a growth spurt, but what happened immediately after the growth spurt? Now she stopped growing for a while, didn't she? Because basically, in the first part, this part, she was growing constantly, continuously, right? And then she had a growth spurt where she was going up faster. But then she stayed the same for a while. She didn't grow for a little while. And then what ended up happening? She started growing again at the same rate that she did before. Make sense? So for questions like that, be careful on a test or a quiz with the wording of how that, yeah, the pen is doing some weird stuff today. Is there a difference between this graph and this graph? To me, they both, let's assume they end at the exact same spot. What's the difference between this one and this one? All right, how do you know it took longer? Longer on the x-axis?
Yeah.
Okay. Let's assume they're the same length now. Are they the same graph?
No, it's like one took longer.
Huh?
It took a minute to get up to that point. That one just went straight to it.
Let's say,
That's all I'm saying. Another one.
well, here's why I'm stopping you. Let's assume this is height and time, right? And let's say it's 16 years and 6 feet tall. 16 years, 6 feet tall, right? At 16, are they the same height? Yes. So it didn't take them longer to get there. It took them the same amount of time to get there. But this one grew what? Continuously, right? This one was a slow, constant rate. What happened here? They were growing, but they were growing slowly at the beginning, right? And then at the end, they had a growth spurt, right? So here, if these are two best friends, who was taller for their entire life? The first one, right? This person was taller, taller, taller. It was only recently that this person caught up to that person. If this were to continue, what's going to happen next year?
This one's going to keep growing.
This one's now going to be taller now, right? Because they're growing at a faster rate now. Make sense? Easy stuff? Don't be surprised on your next quiz or test if I give you a graph like this. Okay, if I give you a graph like this, time versus distance, and you have to describe what's happening to this person. What's happening in here?
He's driving.
Huh?
He's driving at a decent speed.
Okay, driving at a constant speed. Okay. What's happening in here?
Traffic.
Huh?
Down, traffic.
Slowed down?
No.
Stopped. Because now they're stopped and they're not moving, but time is still going on. So basically they're driving, okay? They stopped here. And then what happened here? And now, is he going faster or slower than he was before? Now he's going really fast. Okay, and then what happened here? So now he's crashed, he stopped. Okay, now what's happening? What's happening in this? That's exactly what's happening. Because now think of it in terms of starting place and distance away from where you started. What's happening in this range? They're getting closer to where they started, right? So now they're going backwards. They're actually getting closer to home. So what happened, what could you say kind of happened in this part. Not only are they stopped, but they turned around, didn't they? So now they're coming back home. Now they're stopped. And then what happened here?
Died. He's dead.
He was chilling
No
in
life
his
to
bed.
him.
He was chilling in his bed.
But what happened right in this spot? 0 time happened.
The end of the universe.
And they went from wherever they were to immediately they transported back home.
Oh.
Make sense?
Yes.
Are we good with this section?
Yes.
Cameron, who was that message from? Top right corner of the screen. Coughlin? All right, I'll answer her later. Okay. Section 2. Everybody look at page 239. This is when we were talking about relations, domain, and range. 3 different ways we can describe a relationship. We can do it with a table, we can do it in a graph, we can do it in a map. Easy stuff? That sentence kind of sounded like I was a Dr. Seuss book. We can describe it in a table, we can describe it in a graph, we can describe it in a map. It's kind of Dr. Seussy. Who knows? Maybe Cameron is the next Dr. Seuss. He's going to be Dr. Seussy. Okay. Usually out of this section, the maps are the only ones that cause anybody any confusion because they're kind of new. They're kind of different. We don't use maps very often where we write them. If I say if I give you this and say write the set of points that this goes with, what's the first point? 1, 5, what? 2, 5, and 3, 7. See, Penn's doing some messed up things today. Come on, Penn. So 2, 5, and 3, 7. Yes? Simple? What's the domain of this function? It's all the x values, 1, 2, and 3. What's the range? 5 and 7. Okay. Do you remember, is this a function or not? No, this is a relation. Is it a function? There's a difference between a relationship and a relation and a function. Is this a function? Does anybody remember what a function is? Do you remember the pop machine example that I had in the video, right? Remember the pop machine video where I put my money in, I press the first button, I get a Coke. I put my money in, I press the second button, I get a Sprite. Is my machine okay so far? I press the third button, I get another Sprite. Is my machine broken? Why? You can have multiple buttons have the same pop, can't you? Like we see that all the time. So you can have 2 different inputs give you the same output, can't you? But what can't you have? What would make that a broken machine?
If you press 2 again, you got 7.
Right. So now if I had another line where the 2 goes to the 7. So I press the first button and I got a 5. I press the second button, I got a 5. That's okay. But if I press the second button again and I get a different output the next time, now do I have a broken machine? Yes. Now it's not a function. Okay? Does that make sense? You can't have the same input giving you different outputs. In this form, in map form, you can't have two lines leaving the same point, right? In table or in point form, in this form, table form, if I add that new one here, how do you recognize when do you not have a function now? How do I know by looking at this, if this goes away, come on. Come on, go away. Move. Okay, I'm going to do this. Yeah, now you move. Thanks, appreciate it. Love you. This thing's working so well today. Okay. How do I recognize in this form that that's not a function? How do I recognize? It was this point and this point that made it not a function, right? So you can't have the same y with different x's, right? Was it okay to have 1, 5, 1, 5? Yes, but you can't. This is okay. You can have the same y's, but you can't have the same x's, right? You can. Sorry, you can have 1, 5, 2, 5, right? But you can't have 2, 5, 2, 7. In graph form, if I plot these points, if I have 1, 5, be about there. I had, this thing is really irritating. Come on. Okay. I have 2, 5. Was it okay to have 1, 5, and 2, 5? These 2 points? Yes. And then I had 3, 7 up here. And then I had 2, 7. What 2 points made that not a function? It was these 2, right? That's called the vertical line test. Remember, the vertical line test basically says, can I draw any vertical angle or any vertical line? If I draw any vertical line, if there's a line that I can draw vertically where it would hit more than 1 point, not a function. Does it have to be only one? No. So if I give you graphs that look like, so you guys just tell me yes or no. Function, not a function. Function, not a function. Not a function, because I can draw any vertical line and hit more than 1 point, right? How about that? Function, not a function. That is a function. There is no vertical line that I can draw and hit more than 1 point, right? All vertical lines only hit once. I can draw horizontal lines and hit more than one, but who cares? It's all about vertical lines. How about a question like this? Function, not a function. That's not a function because I can draw a vertical line and hit 2 points, not a function. Does that make sense? The vertical line test is a super, super easy test. It really is. It's just, if you can draw a vertical line and hit more than 1 point, it's not a function. I think graphically, identifying whether something is a function or not is the easiest way to do it. I think the other 2 methods, the other 2 forms are also fairly easy. You know, if we look at, going back to this, it's not hard to see in map form, and it's not that hard to see in table form or point form either, but I think graphic form is by far the easiest. Make sense? Was there anything on page 239, that homework assignment, you would like me to go through? Anything at all. Domain, range. How about question like number 10? Is that one? What was that point right there? 3, 3, 3. I'm going to change this. I'm going to change it to 3, 4, just for this, just so we have different numbers. If I ask what's my domain and what's my range, remember, domain is all the what numbers? Domain is the x's. Right? So where is this graph located on the x-axis? Where are their points? From where to where? Starts at, ends at. So great. It's all the x's basically between 0 and 3. Everything greater than or equal to 0, everything less than or equal to 3. When would I use not equal to? If it was an open circle, right? If it's a closed circle, I got to use it or equal. What's my range in this case? From 1 to what? 4 to 0. So now we're on this axis. So from 4 to 1. So basically, all the y's, that's a 4. From 0 to 4. Easy? Domain is all the x numbers. Just look at the x-axis. Where is the graph located? Range is the y's. Easy stuff? Okay. And then if you look at page, we also did 4.3, all the independent, dependent variable stuff, function notation on 249. To me, the hardest part of this is just the independent versus dependent. And the easiest example I can give is you as in your family. Are you the independent or are you the dependent variable right now? You're the dependent because you depend on your parents. Your parents are the independent, right? What you do, does that affect your parents? Yeah. And does the parents affect the kids? Absolutely, right? So, generally speaking, who decides where you're going? Mom and dad. They're the X, right? You're just along for the ride, right? So you're the Y. Does that make sense? They're the ones making the change. They're the ones making the decisions. You're the ones that are just kind of along for the ride. You're the Y. You're the ones being affected. How is the function notation stuff? Is that really easy? This stuff where it looks like, does anybody remember how to read this? How do you read that? F of x is equal to 2x minus 3. How do you find this? Just plug a 4 in. All I did was change the x into a 4, so great. Change all the x's into 4s. And 8 minus 3 is? Great. F of 4 is 5. Easy stuff? Anything at all out of that first section cause problems?